All right, everyone. Today we are going to have a lesson on taking sinusoidal graphs and writing equations of them. So I have the answers for the homework on here, and you can pause the video as we go through it and check your answers. Any questions you can ask a classmate, or you can wait till Friday and I'll answer those questions. Here are the answers for 1 and 2. Pauses you need, and notice at the bottom that when Ms. Caldwell had made this key, she called it the start, quarter 1, the middle, quarter 2, or quartile 2, and then the end. Pretty sure that's what she had meant by those. So then here's graphs 3 and 4. Here's graphs 5 and 6. And then graphs 7 and 8, but 8 did not get flipped. She had graphed the positive 6 sign there, but the negative, you would have to flip this upside down. So any questions you have, you can just come to class and ask me on Friday. So what we're going to be doing today is we're going to look at graphs and be able to write a sinusoidal function for it, kind of in this form. A sine the quantity b times x plus c plus d. And we're going to see what each of those letters mean and how you find them. So to start off, I wanted to give some background information. And here's where we can start. We know that we have seen this formula before, that the period equals 2 pi over the b value. Well, if you think of this as two proportions, sorry, I'm writing with a stylus and it's not working great. If you write it as two proportions, I think if you guys remember the property where we said you can flip what's on the diagonal, then by doing that, the b goes where the period is and the period comes down to b, and you get this equation on the right over here. So a new formula that we have, and we're going to use this to find the b value for our equation from our graph, is you'll just take 2 pi and you'll divide it by the period. Some of the graphs are in degrees, and if it's in degrees rather than radians, you'll use 360 degrees divided by the period, and that's how you'll get your b value. To find the d, it's a couple ways. One is it's pretty easy if it gives you the midline. You can clearly see it. There's your d value. You don't have to do much work. Another way is that the d, or the midline, the middle line is, and I'm going to get pen on here, the middle line, it's the average of the min and the max. Well, to find an average, you should know that you add two numbers together and you divide by 2. The next one is the amplitude, and there's two ways to do this. One of the ways to do this is you find the distance between the min and the max, and then cut that in half. To find the distance between any two numbers, you always subtract it, so max minus min, and you divide it by 2. Another way is you can just sometimes look at the graph and you can say, hey, the distance from the midline to the max or the midline to the minimum, and that's your A, or your amplitude. The last one that we're going to look at is your C value, and you have to figure out if it's a positive or negative sine or cosine graph. So here's what you have. If it's a graph like this and it's starting at the midline and it goes up, down, down, up, that's a positive sine curve. If it's a graph that starts at the midline and goes down first, down, up, down, it'd be a negative sine curve. Your A value would be negative and you'd have the word sine in your equation. If it's a positive cosine curve, that means your A value is positive and you'd have the word cosine. It starts at the top, comes down to the midline, down to the bottom, up to the midline, and back up to the top. And it's just the flip of that if it's a negative cosine curve. It starts at the bottom, up to the midline, up to the top, down to the midline, and down to the bottom. So that's going to be really the only part you're having to think about in your graphs, depending on where you start, is that C value. So here when we look at this graph, we see, and if you look in your packet right now, pull out your packet, look at problem number 2, and we'll go through this together. So the first thing that you guys should notice is that on here, your x-axis is in terms of degrees, and that's why we're using this formula here, which is b equals 360 degrees divided by your period. And by doing this, we're going to look really quick and say, hey, what's the period here? So here we can see that the period, it goes from a minimum at 4 and then another minimum over here at 44. And how far apart is that? Well, it's 40. So what we can do then is to find the b values. It'd be 360 degrees over 40. And when you divide that out, you get 9. So our b value in our equation will end up being 9. Our D is our midline. So sometimes it's really nice and it's given to us really easily here, but in this graph it's not. So to find the midline, you can do the max plus the min and divide it by 2. Well, it looks like the max is 18. The minimum is on here, -2, and you're going to divide it by 2. And by doing that, 18 minus 2 is 16, and you divide it by 2 and you get 8. So your midline is at 8, and that's what it looks like here. So this right here is the line, y equals 8. Makes sense, it's positive, and if I think about this, how high is this up? Over here on the axis, so from the midline to the top, that's 10. From 8 down to -2, that's 10. Yep, that tells me it's the midline. It's halfway between the top and the bottom. And by doing the work that I just did, I also just kind of found that amplitude. And to know that this amplitude is 10. If you want to see work on it, you can always do your max minus your minimum and divide it by 2, which is 20 over 2 or 10. So 2 different ways to find that. And then to find your C value, you have to determine where am I starting the graph. So there's a couple different ways to do this. I sometimes look for ways to write a positive function. So I'm going to start where this red is here. So maybe let me grab this equation. I'm going to write f of x equals, our a value we said is 10. It's a sine function. Oops, we can do brackets. And then our b value is 9. And then it's x. It got shifted to the right 14, so that's x minus 14. Close brackets, and then the midline is 8. So that is one function that we could have. I'm going to just copy and paste this, and then we're going to come up with another one. I'm going to make this one red because that's the red function where we started. And then let's come up with another one. What about if I were to start a graph at the top here? So this way up here, blue, I'm going to make this equation blue. Starting there, that is going to be a positive cosine curve. So I can change this to be cosine now. And my a value is the same, my b value is the same. The only thing that changes here is my d value to get 24. Got shifted to the right 24, and the midline still 8. Just to add on to here a little bit, I'm going to do one more on here. I'm going to show starting at this green dot right here. Oops, let's do this, and let's do that one more time, sorry. Here where the green dot is, I'm going to then copy and paste this equation, and I'm going to make it green. And here's what happens. Since I'm starting at that dot, at that green dot, and it's going down first, that's going to be a -10 sine, and then it also got shifted to the right 34. So hopefully you're seeing that no matter how I write the equation, my d value is the same, my b value here is the same, my a value is the same, it just might change positive or negative, and then the words sine or cosine change, and the numbers for the C value change. All right, let's move on to the next problem. Let's look at number 10. If you want to pause this to try it on your own and then hear the explanation, now would be a good time to do that. So on this graph, what I would look at is for the period, because I know that this is going to be 2 pi over the period. To figure out the period, I would see that right here, it finished 4 full cycles by time it got to pi, which means that over here, this is 1 full cycle by time it got to pi over 4. So to figure out my b value, it'd be 2 pi over 4. If you forgot, you would how to divide fractions, 2 pi times 4 over pi, or your b value is 8. So that would be your b value in this problem. Your d is your midline. Look how nice it is that the midline's given, that it's the line y equals 4. So 4 is my midline. I don't have to do any thinking on there. A is my amplitude. Amplitude is how far is it from the midline to the top. So from here to here, it's 9. And from the midline down to the bottom, it's 9. You can count. Another way to find the amplitude is you can always take your average of your high and your low and divide that by 2. So if our maximum is 13 and you take away, -5 and divide by 2, you have 13 plus 5, which is 18 divided by 2, which is 9. So either way, you can look at the graph and count, or you can do it mathematically. So if I were to write an equation on this, I'm just going to cut and paste from the previous slide, and I'll change some things as we go. Our amplitude, we said here, is 9. I will come up with a sine curve in a second. Our b value is 8. I'm going to have to come up with that in a minute, and it's 4. So let's see where I want to start this graph. If I start right up here where this red dot is, that's actually going to be a cosine curve. And it's a positive cosine curve. So I'd start here. So it's 9 cosine. 8 times x minus 0. You can just write 8x there. You don't even need that. And plus 4. I'll do one more on here, but I hope you can see that depending on where you start, you can come up with tons and tons and tons of different equations, an infinite amount of equations, because you can keep moving 1/4 of the way over on the graph. Starting at this blue dot right here, it is going to be a negative sine curve. So now my a becomes a negative. I get -9 sine of 8. And I moved 1/4 of the way over, and 1/4 of pi over 4 is, this is going to look really bad, I'm just going to write pi over 16, and then plus 4. So there's 2 equations. All right, so now what I'm going to ask you to do is turn to problem 4. This is the last one that we're going to do together, so pause this video right now and then try it on your own and come back and check the answers. All right, so on here, this one is actually in degrees, and I should look up the whole front page of your packet, just so you know, is in degrees. And I do know that on this one, it's not listed as, or no, is this not number 4 on your packet? No, what is this one? Hold on, sorry. Okay, anyways. Uh-oh, maybe that's not on your packet. Is this? This is not number 4 in your packet. All right, you can try this one regardless. Maybe it's not on your packet at all, and I'm flipping really quick. Or if you can find it. Actually, it is. It's on the 3rd page, and it's number 4 on there. And that one is actually in degree mode. And if you're looking on the 3rd page, just so you know, the ones that are degree mode are 1, 2, 4, and 7. All of those are going to be in degrees for this one. So on number 4, so on this one, here we go. This one is actually 360 over your period. Hopefully you can see your period on here. Where is it going from? And it looks like it's going from -20 right here to 100. So it's 360 over 120. So our b value is 3. Our d value, I'm going to draw that one in purple, and that looks like our d value right here is the line y equals 3, so our d value is 3. Our amplitude, I'm going to do it non-mathematical just by counting, and I can see that as a height of 5. So on here, our equation would be f of x equals, and I'm actually going to start at the very top there. So I'm going to have a 5 cosine. Oops, I already hit cosine there. My b value is 3. It got shifted to the right there. It's actually 10. And this looks like right here it's at 10 right there. We can talk about how we found that in a second. And then our d value is 3. And what I can tell is that if it's going from over here at negative 20 to 100, and that's a full period. If I divide 120 by 4, I'd get 30, and half of that is 15. So hold on, am I thinking about this right? 60, 30. Oh, no, no, no. Sorry, I'm not thinking about that right. If I take 120 and divide by 4, I'm getting 30. So this should be 30 over. So sorry. Way too late to be making a video. So anyways, 30 over from negative 20 is at negative 10, which is how I know it got shifted to the right 10. So that would be one formula. Another formula I can do would be starting here, and that would be a negative sine curve. So I'm just going to copy this equation. And I have f of x equals negative 5 now, the sine, and that would be shifting to the right 40, and then plus 3 at the end, and I can make that blue since it started there. All right, now next two problems I have are actually from actually not in the worksheet in the packet at all. I just want you to take notes on this and try this in your notebook. I'm actually going to just give this to you and let you work on it, and then I will come back and start with this on Friday for you, since this video is getting long. So the New York Ferris wheel completes one full revolution every 12 minutes. The diameter of the Ferris wheel is 300 feet, and it starts moving when you enter at the bottom. So you got to make sure you're reading the directions there. So one rotation every 12 minutes. The diameter is 300 feet, and it starts when you're right there at the bottom. You're going to draw a picture of this Ferris wheel, and there's a Ferris wheel right here. You're then going to graph 2 complete periods of this, which is your height in feet above the ground T minutes after wheel begins to turn. You'll find a sine equation for your graph. Then you'll use your graph to answer questions on how high the passengers are after 3, 6, 9, and 12 minutes. No work is required to do this. And then last part is you'll find out how high off the ground are passengers at 2 minutes and 4 minutes, and use your knowledge of special right triangles, then verify with an equation. Your homework is to do this one problem here, and then also to finish the whole packet that where it's all the graphs writing the equations. Please be good for the sub, and I will see you on Friday. Thanks.